Hi everyone! Now we're on functions. In this video, you're going to learn about how to structure your programs and high details. You will learn about two powerful concepts in programming, such as abstraction and decomposition. And together with functions, you will learn how to about the scope of variables. By now, we know how to write programs, how to write codes, and we already know the programming fundamentals. We know the basic types of variables and data. We know branching. We know if, elif, and else. We know how to create loops using the for and while constructs. Um, we know how to write a source code in one file, and if we are given a problem, we can create a code or a program for that. And then we know that this source code has lines of codes which are actually sequence of instructions. These instructions are commands or expressions. With yeah, basically we know the basics or foundations. With small scale programs, this skill is already okay. We can write codes. However, if we start to work on larger problems, this set of skills may not be enough. If we write our code in one file, and if the problem is big, there may be some parts in the program. Let's say you have a for some at some point, and then that exact same for code block, you want to reuse that in another place or at some another point in your program, maybe at a later part. It may be needed not just twice, and you maybe thrice or four times. So you'd have to copy that piece of that lines of code and paste it at the locations where you would need it. If there is a bug or there's an error with a program, you'd have to modify or change that for loop. And if you pasted that in four different locations or lines, you'd have to edit all those four, and they have to be consistent. So if let's say you have 1,000 lines of codes in one file, that would not be that easy, right? It would be difficult to keep track of the details and to keep track of the flow of your program if you have 1,000 lines of codes. In programming, it's not really having more codes is not the gauge of let's say good program. So it's really having more functionality. So it's better to have a piece of code that has more functionality than a piece of code that has more lines of codes but then with fewer functionality. And we solve this, or we get around this by using or by creating functions. So functions achieve both decomposition and abstraction. What are these two concepts? Actually, these two concepts are very powerful in programming, um, especially when you are used to using this. So let's say I give you parts of an LCD TV, and of course when you receive it, you would say, oops. You'd have to put them together before you'd be able to use the television. Um, Therefore, you would prefer to get a working TV that is in one piece. So it's better to have the TV like this in the second picture, and then you just have to plug it on an outlet, and then turn it on. Choose the program, the TV program you want to watch, or the application you want to load. So a TV is like a black box. You know the input and the output. You know how to use it, but you don't really know how it works. And that is abstraction. We do not need to know how it works, but we know how to use it. We know the input, the output, and what it does. And with the same example, the LCD TV, you're probably familiar with electronic billboards, and this e-billboard displays large image that is decomposed into separate LCD TVs, like here in the image here, like this example. Okay, so each LCD takes input and produces separate output. And all LCDs here in this panel, there are several probably. In this panel, there are several. They all work together to produce a larger image. Each screen may have a different output, and that different output contributes to the function of the whole. And that is the composition. Different devices work together to achieve an end goal. Okay, so these two are very important, the composition and abstraction. And if applied to programming, it's powerful. Okay, so we can create structure with the composition. In the LCD example, we saw this with separate devices. In programming, we can apply the composition by dividing codes into modules. These modules are self-contained. They are used to break up code instead of having a big file or a long lines of codes. And then they are intended to be reusable, these modules. And these modules keep the code organized and coherent, because each module would have its specific meaning or specific task. And then this one, we achieve the composition by creating functions in our program. And we can suppress details with abstraction. In the LCD example, the instructions for how to use it is enough. We do not need to know how to build an LCD TV. We just use it. Similar with programming, we think of a piece of code as a block box. Let's say a module as a block box. We cannot see the details. We do not need and want to see the details. So those tedious coding details are hidden inside the block box. We achieve this abstraction with function specifications or docstrings in Python. So functions are reusable pieces of codes. We write these reusable pieces of codes inside an encapsulation or a function. Functions are not run in a program until they are called or invoked in a program. So if you write a function inside your source code, inside your program, it sits there and it's not run unless that function is called. Function has name, it has parameters, maybe 0 or more. It has a docstring. This is optional but is highly recommended. It has a body and it returns something. So there are two tasks with functions. A function has to be written, and a function has to be called or invoked. So someone writes the function, and that same person, let's say I write the function, I can also call and invoke the function in the main program that I'm writing, or in the code that I'm writing. So it's also possible that someone writes the function and another person calls or invokes the function. So there are two different, somewhat different tasks. Writing the function, so the function sits there. It's unless it's called, the function just sits there. If the function is called, that's the only time the function runs. So there are two things we have to do: writing and calling the function. So let's say we have this example. What does this mean? So this part is a function definition, and this last line here is the function call. So the def keyword that is signifies that this block of code is a function. So this def keyword is used in Python. This def keyword is followed by a name, which is the function name, and followed by a pair of parentheses, and inside the parentheses are parameters or arguments, followed by colon, and then here we have the specification or docstring. So this specification is docstring is optional. However, it's highly recommended to put this all the time, every time you write a function. In this docstring, you have to put the description of the input, the output, and the description of the function. What does the function do? Then after the docstring, you have the function body, or this function body is just like a typical lines of codes in your program. It may run some commands. It may have keywords like return, and it may have expressions to evaluate. And then after that, this is one function definition, and that function is named isEven. And once we have this, once we have written this this function definition, we can now call the function here. So later in the code, you can call the function using its name and values for parameters. Here we pass the value 3. So variables have scope. Now we will discuss scope. This may be tedious, but then I'll try my best to explain it one by one. So here in the function definition, we see the parameter, and this parameter is called formal parameter. This x will not have any value unless the function f is called. And here in the function call, there is a parameter, and we call that actual parameter. The value on this the value bound to this actual parameter is upon function call is bound or assigned to this formal parameter. And a new scope or frame or environment is created when a function is entered. So, well, upon start of the program, a global scope or global environment is created, and that imagine it like a cloud or an environment wherein objects are created and names are assigned to those objects. And upon start of a program, the first environment created is the global or main scope or main environment. And scope is the mapping of the names to the objects. And how this mapping happens, or how the variables are visible or not to the functions, that's what we are going to discuss in the next slide. So here we have the function definition, and here is the main program code. This one here, we initialize a variable x, and the initial value is 3, and make a function called f of x, and the value of x assigned to the formal parameter is 3. And upon exit, so this function f is called, it runs this one, and then sees return statement. It returns to the function that calls it, so it returns here, and then the value that it returned is assigned to z, to the variable z. Let's take a look at this example, and let's try to imagine the variable scope. So let's say we have this function, or well, let's say we have this code, and this one is the console or the output to the user. This is what the user sees on the console. So upon start of the program, we have here def func, and func is the name of the function, and it's created here. The name func is created, and it creates an object which says that it's some code. So what is executed next is there. Control goes here because this is just a function definition. Therefore, the function body is not executed or evaluated. It jumps to here, x equals 3. Therefore, the object 3 is assigned to x, or x binds to the object 3. Next, here, z equals func x. So here, the value of x, so this is a function call. So when the function is called, control goes there, goes to the function. So the value assigned to the formal parameter x of func is 3, because that's the value of x in the calling function. This is the actual parameter, and that's the value assigned here. Take note that when the func function is invoked, a func scope is created. And that's the time the variable objects and names are created in the func scope materialize. Then x x binds to x plus 1. So the previous value was 3, now it's 4. Then take note of this, print this one, and as you can see, this is the output on the console. Then what happens is it goes to return x. Therefore, this object 4 is returned to the global scope. And that object is put here. So this becomes this func x, this becomes 4. That's the object returned, or the value returned by func x. Therefore, Z binds to 4. So the value assigned to to Z is 4. And that ends the program. So that's how the scope of variable uh, works, especially in the context of function. This could be messy later on, especially if you have bigger programs and more complex programs. So if there are no return statement, like in this example, you see there's no keyword return. Python returns the value none. It's a special type. It's non-type. So it represents the absence of a value. So let's take a look at the difference between return and print, especially in the context of function. Return only has meaning inside a function. You cannot put return in the main. And then print can be used outside functions also. It can be used inside a function and outside a function. There is only one return executed inside a function. And with print, you can use you can put many print statements inside a function. So inside the function, if there are statements after the return statement, or if there are lines of codes after the return statement, those lines of codes will not be executed. While with print, it just prints, it executes or runs the command print, and then still continues to the next line of code. With return has a value associated with it, and that value is given to the function caller, as you've seen earlier. While print has a value associated with it, and that is outputted to the console, which you've seen earlier also. So they have different uses or different purposes in programming. So in Python, I've mentioned before that everything in Python is an object, including functions. So function is also an object in Python. Therefore, since function is an object, it can be an argument also. So here in this example, we have function func A, function func B, and func C. And we call those functions in this manner. Func A doesn't have a parameter. Func B, this actual parameter integer 2 is passed to func B. And here in the last line of code here, func C is called, and then the actual parameter passed is func A. This is allowed in Python. Let's take a look at how this one, let's visualize this. And a tool or a way to visualize it is to use this Python tutor. So go to pythontutor.com, and then I just pasted the source code here, the code here, and then click visualize execution. You'll see here, there is a red arrow and then next. Okay, so next, this one is executed. So here in the global frame, you will see that func A, the name func A is created, and it is mapped to a function, func A. Next, func B, and then after func B, func C is created. And here, print, and then we print the return of func A. So before we can print the return of func A is called, so the frame or the scope of func A is created, and there is a print. You will see print. So there, after print, you'll see a text is printed here on the console inside func A, which is this one. And then the return of func A, since there is no return keyword here, the return is none. So this none, value none, is put here. So I'll type next, it goes here. Therefore, the one printed is the return of func A, which is none. There you can see. And then the second print statement is this one. It's 5 plus func B, and the actual parameter passed is 2. We go to func B, it's invoked. So upon call to func B, the func B frame or environment is created, and we have the formal parameter y, and the value of that is 2 because that's the actual parameter passed by the calling function. And then there is print inside func B, and then we return y. The value of y is 2, so the value returned here is 2, and then that 2 is added to 5. Therefore, it prints 5 plus 2, which is 7. Next, the last line of print statement is func C, and the actual parameter passed is func A. What does this, what happens now? So func C, there is a formal parameter Z, and the formal parameter Z is assigned the return of func A. So Z is mapped to func A. And then here it goes print inside function C, and then return Z. So we return Z, but Z is a function call, therefore it calls this one, it invokes this, and then the func A is created, func A environment or frame is created, and it prints, inside func A. The return is none, therefore return is none. And that ends the program. So this tool is very useful, especially if you want to understand what happens to your program. So for simple code or simple program, you can take a look at how the values are mapped to the names of your variables. So let's go back to the slides. So here are some things to remember. So if you are inside a function, you can access a variable defined outside, but you cannot modify it. You cannot modify a variable that is defined outside. A workaround is to use global variables, but that is highly discouraged. So as much as possible when you are programming, when you are writing your code, avoid using global variables. Because if you use global variables, let's say you have one variable, and that variable, one global variable, that one variable may be accessed at different places, and at some point it would be difficult to keep track of the value that's being assigned to it. So let's take a look at this 3 sample codes. So here we have a function named f, and you will notice there is x equals 5 in the main and x equals 1 in the function f. So here x is redefined in the scope of x. These two x objects are different. They refer to 2 different objects. Here in function g, the x here refer to the x outside g. So to the x, to the value of x that is at the or in the scope of the function that called g. So this is the function that called g, therefore the x that this function refers to is this one. Then here in the third example, the function h, you will notice that x here is modified. We try to modify the value of x by assigning x plus 1 to x. This one will result to an error here, and it will say reference before assignment because of this reason. We cannot modify a variable defined outside a function. And this 3 print x, they refer to the x which is in the global scope or in the main program. So the x here, and x here. So here is another example. You will notice here in this example that there is a function definition inside the body of the function g. In Python, this is allowed. So we have a function function h inside the function g. Let's try to look at how this works. I have the source code here, and let me edit this code and paste it here. And let's visualize the execution. What happens is, let's take a look at this. So in the global frame, a function named g is created, and then x with a value 3. And then there is a function call, g is called, and the actual parameter passed is 3. So inside g, there is a function definition, h, which is a function. And then take note that the parent is here, f1. And then we increment x there. It's not 3 anymore, it's 4. And then print statement. So the output is here. And then h, the function h is called. So there, we go to the function h, and then we get x, and the return value is none. So it returns there, and return x. What is x? Here in the scope of g, the value returned is 4. Therefore, goes to, the return is 4. There. The value assigned to z is 4 because that's the return of g of x. That ends the program. Let's go back to our slides. So there, the composition and abstraction, which we apply in programming by using or by writing function. So with the composition and abstraction, um, code can be written once, which is very important. Um, and then with just that one function, we can use that function or we can call that function many times. And since we've written it just once, we debug it just once also. So it has to be debugged once in one place only. We do not have to edit or to modify four chunks of codes or four code blocks that are actually the same. Because we've written it once, we called it many times, and changing the code would mean just changing that one piece of code or that one function of code. So that's the beauty in using in writing and calling functions. Okay, so from now on, what we have to do is write our programs um, with functions, keeping in mind that it's very important to design our program um, modularly or in decomposed manner. Um, so with this one, this is something that we can think about in designing our programs. So most of my lecture materials are from the MIT Open Courseware, and thank you to this Open Courseware, which is very helpful. And Python Tutor, if you want to take a look at how your code works behind the scenes, you can use Python Tutor to visualize your variables. That's all for today, and enjoy programming, enjoy functions. Have a nice day.